Hello, class. Welcome to Module 2, Lesson 16 of 8th grade Eureka Math. And this is the last lesson in Module 2. So we're coming up on the end of Module 2, the beginning of Module 3. And this lesson is kind of a continuation of Lesson 15 about the Pythagorean theorem. In Lesson 15, we learned what the Pythagorean theorem was. Right here, we learned that it showed the relationship between the side lengths of right triangles. Today, we're going to talk about some of the applications of the Pythagorean theorem, how we can use the Pythagorean theorem. So, talking about the Pythagorean theorem, and remember the Pythagorean theorem is connected to the lengths of sides, not the angles, it's the lengths of the sides. And remember the Pythagorean theorem works for right triangles. So we're going to work more with right triangles and side lengths, a little bit of preview today. Yesterday we worked on finding the hypotenuse. Today we're going to focus on finding the legs of the right triangle. And we won't forget the hypotenuse. We're going to show you how the Pythagorean theorem can be used to find in real world situations. So let's give you a little reminder of what we did in Lesson 15 by showing you the right triangle. There is a right triangle, and you can see I have it labeled. I have the right angle labeled, proving that it is a right triangle. A right angle is 90 degrees. I have the legs labeled. Here's a leg and here's a leg, and the legs are labeled A and B. Leg A, leg B. And remember, the legs are the sides that meet the right angle. The legs are the sides that meet the right angle. So the first step is always to check to make sure it's a right triangle. Then you have to locate and label the legs, and they are connected to the right angle. Very important you know where the legs are. And then step 3, locate and label the hypotenuse, and the hypotenuse is this line opposite from the right angle, and it connects the legs. So the hypotenuse is opposite the right angle. And the hypotenuse is also labeled C. So the legs are A and B, the hypotenuse is C. And then the fourth step we did yesterday is we used the Pythagorean theorem to find the missing sides. And here is the Pythagorean theorem here. I hope you have it memorized already. It should not be too tricky to memorize, and we worked with it a lot in Lesson 15. It's a squared plus b squared equals c squared. And remember, this is the lengths of the sides. So the length of side A squared plus the length of side B squared equals the length of the hypotenuse squared. That's Pythagorean theorem. That's what we're using today. And so for today, we showed yesterday how to find a hypotenuse. Yesterday we practiced finding, they gave us the two legs, and we used the two legs and the Pythagorean theorem to find the hypotenuse. The hypotenuse was missing. Now we will find one of the legs. So today's lesson, they're going to give you a leg and the hypotenuse, and we will have to find the other leg. So today they'll give us one leg and the hypotenuse, and we'll have to find the other leg, which means we'll have to do a little bit more algebra than yesterday. Just a little bit. There's like one more step today. You'll see what that extra step is. It will make sense, especially if you remember your work in 6th and 7th grade. So don't freak out about today. If you did well yesterday, you should do well today. So we're going to find one of the legs, and we'll also show some real-world uses of the Pythagorean theorem. So we're going to find out how people use the Pythagorean theorem in the real world. I've actually used it before. The week before my brother's wedding, one of the things my brother wanted to do at his wedding was play cornhole. Cornhole is that game where you toss the beanbags at a board with a circle cut out of it, and you try to get the beanbag into the circle. Well, we were trying to figure out the lengths of our cuts, how to cut the measurements and things. And so we actually used the Pythagorean theorem to figure out, how long we should cut the boards. We were kind of my brother and I were in my dad's backyard being pretty nerdy using the Pythagorean theorem for a woodworking project, but it did come in useful. And so there are some good uses for the Pythagorean theorem. We'll talk about a couple of those today. So that's what we're doing today. Let's do a couple examples real quick. Let me show you some examples real fast so you get an idea of what we're doing. So the first page you're working on is page 177. So on page 177, you'll see example 1 that looks like this. You'll see that they have a right triangle, and step 1, it is a right triangle. There is the right angle, proving it's a right triangle. Step 2, find the legs. So here, so remember the legs are next to the right angle. So here can be a leg, and here is a leg. And I'm going to label them A and B. And there's also the hypotenuse, which is opposite from the right angle, that the side that is opposite, and that is C. So I found the right angle, I labeled my legs, I labeled my hypotenuse, and now I need to use the information I have and the Pythagorean theorem to find the missing side. And this time, you'll see it's a little bit different from yesterday. This time, it is a leg that is missing. And I know they do the work right here. They did all the work here, but I'm just going to do it again and talk about it while I do it so that so maybe it's a little bit more clear if I help you out. So this time, it's the leg missing, and I know A and I know C. So I'm going to still use the Pythagorean theorem. I'm still going to use the Pythagorean theorem. So let me write the Pythagorean theorem again. A squared plus B squared equals C squared. And I'm going to substitute. So A, this first leg, is 5. So 5 squared plus B squared is unknown. So I'm just going to leave the variable B squared. But this time I do know C. C is 13, so it's 13 squared. Already you can see this is going to be different from yesterday, but not super different. So 5 squared means 5 times 5 means 25. 13, B squared stays the same since we don't know what B is. 13 squared is 13 times 13, which is 169. Now you can see I'm not doing this step right here. You can, if you want, add the extra step where you do 5 times 5 and 13 times 13. I'm just doing that step in my head, but you can do it on paper if it makes you more comfortable. But regardless of whether you write it down or not, we have 25 plus B squared equals 169. Now, our goal right now is to get B all by itself. But so we need to move the 25 to the other side. We do that by subtracting 25 from both sides. That's the extra step today. That's the algebra, the extra step today. Because when we do 25 minus 25, we turn that into a 0, and we get B squared. So 25 minus 25 is 0. And so 0 plus B squared is just B squared. But I also have to do minus 25 on this side. So 169 minus 25 is 144. So B squared is 144. But I don't need B squared, I need B. Well, B squared means B times B equals 144. So if B times B is 144, what is 1B? Well, hopefully you know your math facts, and you know that 12 times 12 makes 144. So our answer is 12. This side, the other leg, is 12. So already you can see this is just like what we did yesterday with one extra step. The extra step is right here where we need to isolate B, where we get the B squared by itself by moving the 20, in this case, it was 25 to the other side. So we move, so that is a little bit of algebra, one extra step today, but other than that, it is exactly the same as lesson 15. This time the side's missing, but we'll get it. So what I want you to do right now, look at your notes again, read through your notes, rewind the video if you need to check and add anything to your notes. But check your notes, work through example 1, make sure you understand how to do this, and then unpause the video when you're ready to move on and see some more exercises and work with me on mastering this skill. Okay, class, hopefully you checked your notes, you worked through example 1, and you feel comfortable moving ahead and getting started on some more exercises. So let's work on exercise 1 at the bottom of page 177, where it says, use the Pythagorean theorem to find the missing length of the leg in the right triangle. So we have a missing leg again. Well, make sure it is a right triangle, and so I see a right angle here, so I know it is a right triangle. Let me also label my legs, and I know the legs are the sides connected to the right angle. So leg A can be here, leg B can be here. Step 3, I should label my hypotenuse, and the hypotenuse is the side that is opposite the right angle, so this is the hypotenuse. Now I'm ready to use the Pythagorean theorem to find the missing side. In this case, the side that's missing is this leg that I labeled leg B. But remember, it does not matter what order you label the legs. The legs can be written in whatever order you want. Like if I wanted to, I could say this is A and this is B. Order doesn't matter. The only thing that matters is that the legs are together and that the hypotenuse is on the other side. So let's work through this a little bit. Let's use the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. And now let's substitute. A this time is 15, so we get 15 squared. B is unknown, so we just leave it B. And C is 25 squared. You can see these numbers are pretty big, so it might come in handy if you have a calculator for this. A calculator might be handy for right now. I'm not saying you have to have one if you're very good at these squaring numbers, but it might come in handy. So let's start doing this. 15 squared is 15. I'm going to do the extra step just this time. 15 times 15 plus b squared equals 25 times 25. And then what we're going to do, 15 times 15 is 225 plus b squared. 25 times 25 is actually 625. If you don't believe me, check it with a calculator. That's what you should do, because who knows if I'm wrong, who knows if I'm lying. But I'm pretty sure I'm right. Now for this, now you're looking like this. We will need to find b, so we need b by itself. So let's get rid of this 225 that's with the b squared. Let's get rid of it. Let's make it go away. We make it go away by doing minus 225. 225 minus 225 is 0. 0 plus b squared is just b squared. But the equal sign means everything I do on this side, I have to do on both sides. So I have to do minus 225 over here. And 625 minus 225 is 400. So now we have b squared equals 400. Now you might just want to stop here, except that this can be simplified. 400 actually is a perfect square. What it is, because b times b makes 400, there is a whole number, no decimal, that does make 400. It is actually 20. 20 times 20 makes 400. So the missing side is 20. That's our answer. Because 20 times 20 makes 400. B squared is 400. So B by itself is just 20. So that's exercise 1, using the Pythagorean theorem to find a missing leg. Just like we did in lesson 15, except for you have this piece of algebra right here where you have to isolate the B squared, get the B squared by itself. Let's practice some more with exercise 2. So go to page 178, please. And right here, this is actually a pretty good real world skill for using this. Let's say you have a 15-foot ladder. So your ladder is 15 feet long, and you need to go 9 feet up the wall. 15-foot ladder. So here's our ladder, and we want to paint 9 feet above the wall. How far away from the wall should we put the bottom of the ladder? How far away from the wall should we put the bottom of the ladder? So we know this is a right angle because the wall goes straight up and down, so that's a right angle. We know this leg, which I'll call B, is 9 feet up the wall. This leg is A, which we don't know how far away to put the ladder. And the ladder right here is actually the hypotenuse, C. The ladder is the hypotenuse, which is 15. So we know we want to go 9 feet up the wall. We know the ladder is 15 feet long. How far away do we need to put the ladder if we want to reach 9 feet up? How far away if we want to go 9 feet up exactly? This is where we use the Pythagorean theorem. Pythagorean theorem, which again is a squared plus b squared equals c squared, because we need to find how far away to put the ladder. So you'll notice this time we do not know a, and I did that on purpose because it does not matter which one is a, which one is b. But this time a is a mystery, so I just leave a alone. B is we want to go 9 feet up the wall, so that's 9 squared. And the ladder is, or the hypotenuse is, 15 feet, so we do C is 15 squared. Now we can use this to find how far away to put the ladder on the ground. How far away to put the ladder on the ground? Well, we have a squared plus 9 squared means 9 times 9, which is 81. 15 squared is 15 times 15. And if you forgot 15 times 15, just look back at exercise 1 where I told you 15 times 15 is 225. So 15 times 15, 15 squared is 225. Now we need to isolate the a squared. Remember, we want a squared all by itself. This 81 is in the way. So get it out of the way. Do minus 81, because 81 minus 81 is 0. And a squared plus 0 is a squared. But if I change this side, it has to stay equal. So I need to do this side also. So I need to do 225 minus 81, which is wrong color, 144. 225 minus 81 is 144, which is a perfect square. So we know a squared means a times a equals 144. So if a times a is 144, a by itself is just 12. So a 15-foot ladder, if it wants to go 9 feet up, has to be 12 feet away from the wall. So we need to put the bottom of the ladder 12 feet away from the wall if we want to go 9 feet up the wall. So because this was a real world word problem, I had to label my units and explain my answer. Don't just say A equals 12. tell me what the 12 means, because this is a real world problem. You have to tell me what the numbers mean when the problems are real. There we go. So that's number 2. We found the missing leg, and this time it will help us put the ladder at exactly the right point. And it's always good to put the ladder at exactly the right point. Speaking as someone who used to help my dad with a lot of projects, it is not good when your dad has to, yell at you for putting the ladder in the wrong spot. So maybe the Pythagorean theorem will save you from some family drama. Exercise 3, let's move on. Page 178, bottom is exercise 3. Now this one is a graphing question. It says find the length of segment AB if possible. Well, it is possible. It is possible to find out exactly how long this is. Now you might be saying, of course it's possible, Mr. Barrett. I'm just going to pull up my ruler and measure it and tell you exactly how long. Well, yes, I suppose you could do that if you really wanted to. But what I would like to do is I'd like you to use the Pythagorean theorem to solve it. To do that, we need AB to be, because we want to use the Pythagorean theorem, we need a triangle, a right triangle. We don't just, the Pythagorean theorem only works for triangles. This line segment is not a triangle yet. So let's make it a right triangle so we can use the Pythagorean theorem. Now I'm going to add legs. So I'm going to add a leg here. And I'm going to add a leg here. And you can see that that is a right angle. That is 90 degrees, which means now segment AB is the hypotenuse. So now this shows me how I can find any line I want. You give me a line, I can find how long it is exactly if I turn the line into a triangle, into a right triangle. So I turned AB into a right triangle by adding legs and a right angle. So now let's label. I'm going to say this is leg A. This is leg B, because they are connected to the right angle. And the hypotenuse C is segment AB. So segment AB is now equal to C, the hypotenuse. Now still, I need to find segment AB. Well, to find the hypotenuse, I need the legs. Well, this, because it's on graph paper, I can just count to find the legs. Like, look, A is 1, 2, 3 units long. So A is 3 units. B is 1, 2, 3, 4 units up. So B is 4 units. And because it's on graph, I could just count, and I know it's 3 boxes, and this is 4 boxes. So now I know A, I know B, I can find C using our Pythagorean theorem. So let's do A squared plus B squared equals C squared. A is 3 units. B is 4 units. C, what I want to find, segment AB, we don't know yet. That's what we're looking for, so just leave it C. 3 squared means 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. C squared we don't know. No extra step here. We just do 9 plus 16, which is 25, equals C squared. So 25 equals C squared, which means 25 equals C times C, which you know your math facts, you know C is going to be 5. C is 5 because 5 times 5 makes 25. So if C equals 5, then segment AB is also 5. So 5 equals C, and C is segment AB. So we say segment AB equals 5 units. We say units because it's on graph paper and we don't know what a unit is. We just know one box is 1 unit. But that is how we found the line. Remember, we did not start with a triangle. We started with just a line. But we made the line into a triangle to help us find it. Super useful tool if you ever need to find a length of a line on a graph paper. Just turn it into a right triangle and use the Pythagorean theorem. Let's keep going. We have a couple more exercises I want to work on. Exercise 4 on page 179. We have a rectangle this time. Given the rectangle with the dimensions 5 centimeters and 10 centimeters, find the length of the diagonal if possible. So they give us a rectangle that is 5 centimeters tall and 10 centimeters long. And they want to know this diagonal right here. Maybe, and I don't know why they want to know this, but you can come up with a real world thing like this. So for example, let's say this is someone's backyard. Someone's backyard is a rectangle, and they want to build a path, maybe out of stone, that goes a diagonal across the yard. So using the Pythagorean theorem, we can find this diagonal. So you can already see here's a right angle. So we can use the Pythagorean theorem because this is a right triangle. The legs connected to the right angle. Here's our leg. One leg is 5 centimeters. The other leg is 10 centimeters. Those are the legs connected to the right angle. So leg B, leg A, and the diagonal, maybe for the pathway, maybe for whatever, that is the hypotenuse because it is opposite the right angle. It is C. So now we have everything labeled. We're ready to use step 4. Use the Pythagorean theorem to find this diagonal right here that we don't know yet. So A was 5, so 5 squared. B was 10, 10 squared. C is the unknown diagonal. 5 times 5 is 25, plus 10 squared. 10 times 10 is 100, equals C squared. 100 plus 25 is 125, equals C squared. Now, I would love to tell you that you can simplify that more, but 11 times 11 is 121, and 12 times 12 is 144. So 125 is going to be like 11 point something times 11 point something. It's not going to be a perfect square. So you can say that C squared equals 125 centimeters, or you can say C, just like lesson 15, by itself is going to be the square root of 125 centimeters. Both answers work for me. You don't need to worry about square roots today. There is a button on the calculator that will tell it to you, but you don't need to do it today. Just if you found C squared is 125 centimeters and C is the square root of 125 centimeters, you're fine. The one important thing is that you labeled centimeters because that is the units we're talking about. Remember, every time they give you units, they want you to label the units. There we go. That's example 4. Let's move on to exercise 5. A right triangle has a hypotenuse length of 13 inches and a leg with 4 inches. What is the length of the other leg? Now, this is an interesting one because they did not give you a diagram this time. Now, you could, if you want, draw your diagram. No one is going to stop you from drawing your diagram and then label the right angle and then label what they tell you. So it says hypotenuse of length 13. So you can say the hypotenuse is 13. That is going to be C. And then the legs A and B. And they said a leg has a length of 4. So you can draw and label one if you want. If it helps you, absolutely draw and label it. No one is going to say don't draw. Or if you want, you can just say, okay, just look at the words and say, a right triangle has a hypotenuse of length 13. So the hypotenuse is C, and that's going to be 13. A leg is 4, a leg with 4. So you can say leg A is equal to 4. And then what is the length of the other leg? So the other leg is B, and it's asking, and that's the question, so we don't know. So you could draw a diagram if that helps you, or you just label like this. And then you're ready for the Pythagorean theorem. A squared plus B squared equals C squared. You labeled A is 4. B we don't know, so that just stays B. And C is 13, so 13 squared. So now we're ready to solve this. 4 squared is 4 times 4, which is 16. B squared stays B squared. 13 squared is 13 times 13, I'll just tell you, is 169. So now we have 16 plus B squared equals 169, but remember, we want to get B squared all by itself. So to do that, we need to make the 16 go away, do minus 16 on this side. 16 minus 16 is 0. 0 plus B squared is just B squared. But if I change this side, I have to do the same thing over here. So to do 169 minus 16, which turns into 153. So B squared is 153. Now B squared is not a, now 153 is not a perfect square. It is, the answer is going to be somewhere between 12 and 13. Because 12 squared is 144, 13 squared is 169. So this is going to be 12 point something times 12 point something. But luckily, you don't have to figure that out right now. You can just stop here and say that B squared is going to be 153 inches. Remember, it's inches because they said inches in the question. Or if you like the square root, you can say B is going to be the square root of 153 inches. You can write your answer either of those ways. Both of those are correct. B, you can keep the B squared, or you can do the square root. The last exercise we have, exercise 6, find the length of B in the right triangle below if possible. So this was super nice. They already labeled this is B when we need to find it. So we check, it is a right triangle. We checked. We know if this leg is B, this leg is A, and the legs are touching the right angle. And the hypotenuse opposite the right angle, C, is going to be 11. So we're going to use that information to find the missing leg. So let's do the Pythagorean theorem. A squared plus B squared equals C squared, using the information they gave us and the labels that we made. A is 4, so 4 squared. B is what we're looking for, so that stays the same. And C is 11, so we have 11 squared. 4 squared is 4 times 4, which is 16. B squared stays the same. 11 squared is 11 times 11, which is 121. Now, just like before, we want to get B squared all by itself. We want to isolate it. So we need to make the 16 go away. So we do 16 minus 16 to make 0. And 0 plus B squared is B squared. But the equal sign means we need to keep it balanced. So we do minus 16 on both sides. So we find out that 121 minus 16, B squared is going to be 105. And again, that is not a perfect square. The answer is somewhere in between 10 and 11, because 10 times 10 is 100, 11 times 11 is 121, 105 is somewhere in the middle. So we're going to stop right here, and we can say b squared equals 105, or b equals the square root of 105. B times b is 105, but b by itself is going to be the square root. And that's the answer we have for exercise 6. All of this was using the Pythagorean theorem and some simple algebra to find what was missing. Hopefully you follow along pretty well. You understood everything. If you need to go back and rewatch the video, do that. Go ahead. If you need some more help from me, make an appointment with me to ask some questions so that I can help you, because I want to help you understand this. But that is the end of the exercises. Take a minute to look at your notes, look at all the exercises 1, 2, 3, 4, 5, and 6, and pause the video to see if you have any questions you need to ask. Unpause the video when you are ready for me to talk to you about the problem set and the exit ticket. Okay, class, welcome back. Hopefully you paused the video a little bit and you checked your answers for exercises 1 through 6, and you have a pretty good idea of what you're doing. You know everything. Or you have an email out to me or a message to me asking for some help. Let's right now talk about, well, page 180, next page, which is the lesson summary. This is just telling you that you can use the Pythagorean theorem to find an unknown leg of a right triangle. It also tells you can use the Pythagorean theorem to find the diagonal of a rectangle or the distance between points on a coordinate plane, on a graph, or even the height of a ladder. So it's just saying Pythagorean theorem can help you find legs and can be used in other real-world situations. The next page, page 181, is your exit ticket. We'll just talk about that last. I'll just set it to the side, or I'm going to slide it to the back of my packet. Then after that, page 183 and 184 is your homework helper, where they give you a few more examples. They give you the question, they give you the answer, the work, and they give you the out loud thinking that the person is doing. So you can read some examples of what you are supposed to do. Some of these, this is exactly like the work you're going to see on the problem set and the exit ticket. So make sure you're using the homework helper if you need it. After the homework helper on page 185, you'll see our problem set, or the beginning of the problem set. I think the problem set is 3 pages today. That's fine. Number 1, find the length of segment AB. Well, that should sound familiar because we did the exact same thing together for exercise 3 on page 178. All you do this time, remember, just turn this into a right triangle. Turn it into a triangle. Just add, this is the hypotenuse. Just add the legs. If you want to see, just go back to exercise 3. Number 2 is our ladder question. It's another ladder. This time they're asking if you have a 20-foot ladder and it is the bottom is 12 feet away from the wall, how high up can you reach? So this one is super similar to exercise 2 on page 178. So try your best. Go back and look at exercise 2 if you need some help. Number 3, a rectangle has dimensions 6 inches by 12 inches. So it's a 6 by 12 rectangle. What is the length of the diagonal of the rectangle? So you're finding the diagonal rectangle. So number 3, they did not give you a diagram. Maybe you want to draw your own diagram. So you can draw your own diagram, and you can also look at page 179 and exercise 4 on page 179. Exercise 4 on page 179 is just like that one. Problem set number 4, determine the length of the missing side. So we just have a missing side right here. This is what's going to be helpful for this one. If you look at exercise 1 on page 177. Page 177 is very similar to this question. Going on to page 186. Page 186 has determine the length of the missing side, if possible. So again, you're finding one of the legs. So again, look at exercise 1 on page 177. And number 6, determine the length of the missing side. A leg is missing. So again, look at exercise 1 on page 177. There are other exercises that do the same thing. So for example, you could look at exercise 6 on page 179. That does pretty much the same thing. But any of the exercises from today will help you with this. So number 7, again, you're looking for a missing leg. So if you want, you can look at exercise 6 on page 179 or exercise 1 on 177. Just about everything will help you on this. The last problem set question, number 8, guess what? Determine the length of the missing side, if possible. So again, one of the legs is missing. That reminds me of exercise 6 on page 179. So there's a lot of questions from the exercise to help you. This is just practice with Pythagorean theorem with your little bit of algebra. And remember, all of my answers will be posted online, so you can look at my answers to check yours. After you do all this work and you check all your answers and you feel confident, you should move on and work on the exit ticket on page 181. The exit ticket is going to be very similar to the exercises we did together and the problem set. So like for number 1 on the exit ticket, you can see, oh, this is a rectangle. They gave me a leg. They gave me the hypotenuse. You need to find the missing side of the rectangle. Let's find this side right here. That should seem very familiar. Number 2, this one's a little bit tricky. It says find the length of all 3 sides of the right triangle. So it's not asking for the leg. It's not asking for a hypotenuse. It's asking for all 3 sides. How long are all 3 sides? I think you can do that. I think you'll do well. I don't think you should have many problems, but again, if you have problems, you can always reach out to me. Make sure you check your answers on the problem set with mine, and make sure that you take a picture of your exit ticket and turn it in onto the Google Classroom. Do your best on this. Reach out, ask questions if you need help, and I'll see you next time. Have a great day.